Now let's go ahead and create the tables, and I'm gonna squish this down a little bit so I can hopefully see both things at the same time. Let me hide the tools pane. Okay, and then move that. Okay, so should be good. So I'm going to start with profile. Create table mg under profile. And then the syntax is like so. So inside of this open paren, close paren, I'm going to have a set of fields. And so I want user ID, which is going to be the primary key in the profile table. So I need to pick a data type for this next, and I'm going to use a numeric value that's automatically incremented, automatically generated. So this is a surrogate key, and it's going to auto number every time I add a row. I don't specify an ID, it just gives the next one on the list. That's called identity. So what I want is, let's say, a number, numeric, and say 10 wide. That'll give us 10 million posts. Maybe we'll do 13 wide, which is the default. And then nothing after the decimal point. And then this is a primary key for the table. And then I'm going to auto number. Now, when you use identity, you can just use the default like so, or you can give it a starting number. So I'm going to start at 100, and then how much you want to go up each time you add a new one. So I could do 100, comma 1, for example, and I'd get ID starting at 100, 100, and then going up by 1 each time. Or I could just start at 1 and go up by 1 each time, and this is sort of the default. And then the next column is first name. And then there's a bunch of different choices here. I can either make this a fixed width or I can make it variable width. Fixed width is char type. Unicode is nchar, so nchar is fixed width Unicode. Varchar is variable length. Nvarchar is variable length Unicode. And so I'm going to use nvarchar. And then I can set a maximum width on this, so let's go ahead and set 256 as the maximum width. This maximum is not actually enforced for all databases, but the size you pick here can affect how many bytes it uses to represent the length for variable length values. And then I have a choice between whether I want to allow null values or not. And in this case, so null values are a little special when you're talking about primary keys and foreign keys, but for just regular attributes like this, basically it's just whether you want to allow the user to create a profile without filling in first name, last name, email, and homepage. And since this is optional to begin with, I'm going to make all of these accept null values. And then I can also specify whether the value needs to be unique or not. So am I going to allow multiple people to have the same first name, last name, email, and homepage? And let's go ahead and say first name, last name. I'm not going to make these unique, but email, I will make them unique. So that's all I need to specify for this one. And then last name is going to be the same thing. So that's an nvarchar 256 null. And I believe null is the default there, but I'll specify it anyhow. Email. Let's make that 256 wide as well, which may not be enough here. But we'll use nvarchar. This one I'm going to make not null, and I'm also going to make unique. So only one person is allowed to have one email address. And then homepage, let's make this nvarchar 65536. And in fact, you're not allowed, are you allowed to have Unicode in URLs now? I think you are. So I'll go ahead and leave it like that. And we'll allow this to be null, and we won't require it to be unique. So actually, homepage has an invalid type. I don't think it likes this, so let's just make this be max. Okay. So there's our first table, and then we're going to worry about foreign key constraints and other kinds of constraints later on. So I'm just going to create tables now. So here's my user table. And this is going to have a user ID column as well. And actually, what I'm going to do is, since profile must have a user, but user may not have a profile, instead of making this one auto number, I'm going to make it be primary key, but I'm going to explicitly specify the user ID when I create this profile record. And the place I'm going to get the user ID is actually from the user record. So I'm going to create the user record. This is going to be auto number. That's going to give me the next ID for the user. And then if I create a profile, I'm going to base it off of that. So this one isn't auto number. But this one is. So I'm going to create a new record. That's going to get a new ID. I'll use that to create the profile. And then I have a username. Let's make that nvarchar 256. And then this is mandatory. And it also is unique. So I'm not going to allow two users to have the same name. And you'll notice that this is basically meets all the requirements to be a key value. So if it's not null and it's unique, I could use the username as the key for this table. But I'm going to go ahead and auto-generate a surrogate key value anyhow, because it's convenient to work with a numeric ID instead of a blob of text that's variable length and up to 256 characters long. And then password hash, that's going to be a character data type. And then the length of the password hash depends on what kind of algorithm I'm using to generate the password hash. So let's look at some common values. So let's look at like SHA 256. And so this is 256-bit signature, 8 bits per byte. And so this is basically 32 bytes. So we could use 32 characters here, but usually this is expanded into hex digits in ASCII. So you get 64 bytes of ASCII text representing hex values. And then sometimes there's padding for assault and other stuff. So so really the easiest way to figure out what you need is to look for 256 hash length. So let's make that char 64. And this also is not null. It's not unique though, because you could have more than one person that ends up with the same password hash. If you salt your passwords properly, the odds of that happening are extremely rare, like 1 in 2 to the 256th power, which is just a really, really, really unlikely thing to happen if you salt them properly. But it is possible, so I'm just going to leave that not unique. And so that's my user table. And then let's go ahead and scooch this over. So create table discussion actually MG discussion. And this is going to have a discussion ID. And this is going to be auto-numbered and created when I create a new discussion. And it's going to have an FK owner ID, which is a foreign key that should match this value here. So it should be the same type. So FK owner ID numeric 13, 0. And then since I must have an owner for each post, if I look at the relationship here, I see that each discussion must have exactly one owner. So that means that this value cannot be null. And then think about what it would mean for this value to be unique. So if this value is unique, that means that each discussion has to have a different value of user ID. And if you think about that the other way around, it means that each user can only create one discussion. Now, the idea here is that a user can create multiple discussions, and that means that multiple discussions are going to have the same value for FK owner ID. So what I want here is actually not unique, which is the default. So the way this is going to work is if you have a 1 on this side for the maximum, then this foreign key is going to be unique. If you have a many on this side, then the foreign key is going to be not unique. And usually this is 1 to n, and so usually this is going to be not unique. And then I have name. So this is the name of the discussion. And let's make that in varchar in 256. Okay, so there's my discussion. And then let's do post next, and then we'll do rating. So I have a post ID, which is going to be auto-numbered. And I have FK parent ID, which has to match the same type as post ID. And then each post has exactly one parent. Actually, it has 0 or 1 parent. And so if it has 0 parents, that means that the value here is going to be null. So I want to allow null values. And then a parent can have multiple children, which means that the value for FK parent ID for multiple posts is going to be the same. So if I have 3 posts that have the same parent, FK parent ID is going to be the same for those 3 posts, which means that this is not unique. And so that's all I need for this one. And then FK discussion ID, that's going to be the same type as the discussion ID in my NG discussion table. And then each post must have exactly one discussion, and a discussion can have many posts. So this one's going to be not null, and it's going to be not unique. And then FK user ID, the person who made the post. So that matches a user ID. And then this one, I have to have a user, so it's not null. And a user can make multiple posts, and so there's going to be multiple posts with the same user ID, so this is not unique. And then I move on to title, and let's use nvarchar 256 for that. And I'm not going to allow empty titles as a business logic decision. I am going to allow duplicate titles, so I'm not going to have a unique constraint there. Content, that's going to be a big blob of text, so I'm going to use nvarchar max for that, and I'm going to make that not null. You could have an empty post, but that's just an empty string, which is different from null. And then posted date, and let's make that a date time, not null. So there's my mg post. And then the last table is rating. And rating is a little special because it actually has a composite foreign key. I'm sorry, a composite primary key. So all of the other tables we've looked at have used surrogate keys for the primary key. This one we're going to use a composite key for the primary key. And so instead of using primary key constraint on the column, I'm going to add the constraint to the bottom of the table definition. So let's see what that looks like. So I just have two columns. I have a FK user ID, which matches user ID. And then a user can rate multiple posts, so there's going to be multiple ratings that have the same user ID. And multiple users can rate the same post, and so there's going to be multiple users with the same post ID. So neither of these is unique. That's why I can't use them as primary keys. But they are going to be not null because you'll see there's exactly one user and exactly one post. So this is going to be not null, but not unique. FK post ID is also not null. And then I'm going to add a constraint, foreign key FK user ID, FK post ID. I'm sorry, that should be primary key. Okay, so I'm not getting a syntax error highlighting, so I think that's probably okay. So let me go ahead and save this, and then I'm going to execute it, and we'll see what happens. Okay, so now if I go to my CIS 275 sandbox X and reload, and then I go to tables, okay, so I have MG discussion, and here are the columns for that. So I have discussion ID, which is a primary key, FK owner ID, and name. I have post, which has post ID as the primary key, and profile, which has user ID as the primary key, and you'll also notice that email is specified as not null there. And then rating. So you'll notice that both user ID and post ID have these little silver keys next to them, meaning that they're primary key, but they're both, actually it says they're not null. Yeah, that's right, not null. And then user. So all of these tables look good. So if I try to execute this file again, I'm going to get some errors. So it's trying to create mgprofile, and mgprofile already exists, and so it's not going to overwrite it. What it's going to do is just give me an error, and then everything else after this go before the next go is going to be in the same transaction, and basically everything after this fails. So if I want to run this thing again, I have to drop all of these tables before executing the create table again. And if you know the table exists, you can use a statement drop table mgprofile, like so. And if I execute that, it dropped the table. But now I get an error, cannot drop the table because it does not exist or you do not have permission. So I tried to drop this table after I dropped the table, and that gave me an error. So really what you want is, there's a statement in SQL Server 2016 that's drop table if exists, and then you give it the table name like mgprofile. And this says if the table is there, drop it. If it's not there, then don't drop it. And so it avoids having the error. Then it's always safe to do this part. So this is always safe to do, won't get an error. The problem is this is only in SQL Server 2016, and I believe cisdbss.pcc.edu is running SQL Server 2014. So you can get the same effect in earlier versions of SQL Server, but it's a little more obscure. So I'm going to pull up the browser and I'm going to search for drop table if exists SQL Server. And then there'll be a Stack Overflow. Actually, I'll just take this first one. So this is talking about the new thing. But it probably has, yeah, so here's the old thing. So here's how you write a conditional drop statement. And this is for dropping a table. And so I'm going to go here. And I'm just going to paste that in. And then this is going to be, that DBO is optional, I believe. So let's change the name to mgprofile. So if mgprofile is not null, then I'm going to drop table mgprofile. Okay, so let's try executing that. And that works. And if I execute it again, I don't get any errors. And if I create the table, that works. And if I execute this, that works. So I think that's what I want. So I'm going to go ahead and duplicate this. Let me tab it over correctly. And then I have 5 tables. So mgprofile, mguser, mgdiscussion, mgpost, and mgrating. And then I'll put a go here. And then I'll execute my create statements. So no matter what state I'm in, this should work without errors. So I'll hit execute. And then let's go back up here and reload again and look at my tables, make sure I have all 5 of them. I do. So I have all my 5 tables. So now I can just edit this SQL file and rerun it and recreate the tables from scratch.